Hi everyone. So in our future year question FYQ series, the next subject is analog electronics. So now we are starting with MOSFETs. So we are going to see the questions on MOSFET in this particular lecture, right? And again, I am saying the questions are of pretty good level. So if you are not able to solve, then don't be demotivated. Try learning a lot of new things from the video because these concepts will certainly be introduced in your upcoming examination. So don't be demotivated. Watch this video as a learning purpose or as a revision purpose. Okay, so don't be demotivated if you are not able to solve the problem, because this is the time when you need to keep your confidence high. Just believe in your preparation and try learning new things from the video. Okay, yeah, thank you very much. Now we will start from the first question. So the next question will be on the MOSFETs only. Thank you very much. Let's see this question. This is also very interesting one. Straight from our class notes only, and I copied it from NPTEL assignment. So basically, what we need to find, we need to find small signal voltage gain. So certainly we would be needing GM value, and all these parameters are same for everyone because only one is mentioned. That means same for everyone. So for GM value you need. So for GM value, what is the formula? Root 2 into mu n CXW by L, that is 100 micro, into ID. So this is 200 microampere current, and if you do the DC analysis, if you do the large signal analysis, then this capacitor will be shorted and both will be in current mirror. These two will be in current mirror. So 200 microampere will be copied here as well. So in all the transistor, 200 microampere current is flowing. So current is also 200 microampere. Are you getting this point? C2 will be open circuited, so 200 microampere current will be copied. So in all the transistor, 200 microampere current only flowing. Okay. So for all the transistor, this would be 200 microampere only. So GM value I am getting 200 micro Siemens. This is the GM value we get. Okay. What we need to find? We need to find small signal voltage gain. Have a look at the V naught value. Okay. This is the most important part. Now what we will do? We will make the AC circuit. So if we make the AC circuit, what will happen? This will be shorted. This node will be grounded. So this node will also be grounded because 0 will travel from here and 0 will go here. Okay. This node is grounded. This will again be grounded. So basically this node will be shorted only. This current source will be gone. This current source will be gone and lambda is 0. So what this will be replaced with? 1 by GM only, right? This will be replaced with 1 by GM. I hope you know this much of basics. The current will be gone. Now how this current mirror, how this part will be replaced? How do you replace this part? 1 by GM parallel with R0 from this direction. 1 by GM parallel with R0. So you will be replacing it with 1 by GM. What is the value of 1 by GM here? 1 by 2 to the power minus 4 to 5 kilo. So from this side you are getting 200 kilo. So here 5 kilo and 195. So this is 200 kilo. Right? 200 kilo. Then there is this C2 will be shorted. This is 100 kilo. This is your V in. And then there is this. It's the DC bias. And then another MOS will come here in this manner, and this is grounded. This is your V0, and this is also grounded. This is your 60 kilo. This is the equivalent circuit you are having. But have a look at the V0. So what will be the potential here? V in by 3, right? The potential here will be V in by 3 because V in this will drive 0 ampere current. So sorry, 2 V in by 3. 2 V in by 3 because across 200 kilo ohm, 200 by 300 into V in. So 2 V in by 3. So what will be the current here? 2 GM V in by 3. And since R0 is infinity, that same current will be flowing here. So can I write my V0 is equals to 2 GM V in by 3 into 60 kilo ohm? Is that correct? No, that is wrong. This is not your V0. This is your this potential VA. Although minus sign will be there. Minus sign will also be there. So minus 2 GM V in by 3 into 60K. This is your VA, not V0. Your V0 is VA minus VB. Are you getting this point? Your V0 is defined as VA minus VB. So first you need to find VA and then you need to find VB. Then you can write down V0. Okay. So minus 2 GM. GM is 2 into 10 to the power minus 4 into 6 into 10 to the power 4 divided by 3 into V in. That is VA is equals to minus 8 V in. So VA is equals to minus 8 V in. This we are getting. Now let's talk about VB. So how will you find VB? So in the upward direction you are having GM-VB current. Say yes or no. Here if I say this is my VB, so in upward direction how much current you are having? GM-VB. GM-VB current, right? So what I can write? GM-VB is equals to minus 2 GM V in by 3. Say yes or no. Did you understand this point or not? In upward direction you are having GM VB current. In downward direction you are having 2 GM V in by 3 current. Both current are equal only. Just the direction is opposite. So both are equated. So from here what I am getting? VB is equals to minus 2 V in by 3. So you should have the aptitude of solving these kind of problems as well. So VA value you are getting, VB value you are getting. V not simply you can write down. So anywhere these kind of questions can come up in your examination in front of you, and then you will be thinking, okay, this is very tough. But this is not tough. This is very straightforward circuit, nothing else. Very straightforward circuit. R naught is 0, R naught is infinity here. So that simply it is very easy. Just you need to have a good aptitude. If you have a good idea of MOSFET circuit, these kind of like 20 or 30 questions we have solved in our full course, right? These kind of circuits we have solved. So with that you will be having good amount of practice. So V naught will be equals to minus 22 by 3 V in. So the gain is minus 22 by 3 volt per volt. Okay. So this is the gain we are getting. So the gain is not minus 8. This is minus 22 by 3. So answer is B. Okay. Let's see this one. You need to find the R in from this particular port, from the port AB. From here you need to find R in. So this is also a very good problem. So from a port I need to find. So what I will do, I will connect a battery V here and get current I out of it. This is what we do when we need to find the resistance. So my R in will be equals to V by I, right? Or what I can do, I can call this one as V1 and this one as V2. So my R in will be, what is my V? V will be V1 minus V2 by I. So this is my V1. So this is my V1 and this is my V2, right? From here to here, what do you know? That this is your R naught, right? And from here to here also, what do you see? This is also your R naught. There could be multiple way of solving it. This is what I thought. Okay, this clicked to me, this manner clicked to me, so I am following in this manner only. This is your V2. Okay. Now I need to write down the equation. So this is your I, and here also I am having I current. So my I current is equals to this current V naught by R naught plus the current in MOS. So current in MOS I don't know, so I assume this potential is X. So what will be my current in and MOS? That would be GMX. And what will be the current here? That would also be GMX, right? So I see very interesting thing here, that my current I is equals to V1 by R naught plus GMX. And this current I is equals to what? This current I is equals to, this current I is outward current, not inward current. So you can say minus I is equals to GMX plus V2 by R naught, right? Do you agree to this point? GMX plus V2 by R naught. Or you can say this negative sign I can pick here. So I is equals to minus GMX minus V2 by R naught. Now I add up both of the equations because I do not want X. I do not want X in my term. So I will add up both of the equations. So what I will get? 2I is equals to V1 minus V2 by R naught. So from here what do I see? R in, that is equals to V1 minus V2 by I. That would be equals to 2R naught. Here it is. Okay, straightforward. Not straightforward, but it should click. It should have been clicked. It would take around 3 to 4 minutes, but it will click. Certainly it will click. Okay, I solved it also as a new question only. It clicked to me. I will put V1, V2, and if there is any intuition behind it, because this X node is going to 0, right? This R node and R node are coming in series. Basically, this is the answer. 2 R node. That means R node and R node are coming in series. So this X node is going to 0. Can anyone tell why it is happening? I will think of it. Okay, I will certainly think of it, and I can see like why it is happening. This will go to 0 only. So I will think of it and certainly it will come. So, or by this method, only two equation we needed to write. Okay. Let's see the solution of this one. This is very interesting problem. I guess few of you might have messed it up. What is the error you could have done? You could have clicked on this one, that this is a cascode amplifier. Are you really sure this is cascode amplifier? No, this is common source amplifier with degeneration and cascode current source in load. Okay. Common source amplifier with degeneration, cascode current source in load. If it was cascode amplifier, then Vin would be here. Okay. What is this? When I was teaching you cascode amplifiers, there I have taught this circuit, and I told you many people get confused. So that's why I asked this question. This is common source amp with the degeneration. And what is there? Cascode current source in load. Okay. So output resistance, you know, this is a very standard circuit. So this will be replaced with R0 only. So very standard circuit it is. What will be output resistance? So this will be replaced with RO1. So output resistance will be GM2 RO2 RO1 parallel to, this will be replaced with RO4. So GM3 RO3 RO4. Right? Very standard circuit it is. What will be its transconductance, capital GM? Will that be equals to minus GM3? No, that would be equals to minus GM3 upon 1 plus GM RS. So 1 plus GM3 RS. What is that RS? RS is RO4. This will be replaced with RO4 because this is DC bias, this will be gone. So this will be replaced with RO4. So minus GM3 upon 1 plus GM3 RO4. So this is how the GM would be replaced. This is your R0. So what will be the gain? Gain will be minus GM3 and then this resistance. This is the approximated gain. And parallel to this, these things will come, RO3 RO4, and in the denominator 1 plus GM3 RO4 will also come. So this point, approximated gain, this is wrong. Approximated R0, this is right. This is right. This is not right. This circuit is cascode amplifier? No, this is not cascode. This is common source amplifier with degeneration and cascode current source in load. So cascode current source is used as a load? Yes. So 1 and 4 are correct, 2 and 3 are not correct. So if someone was in hurry, then he would have clicked on 1, 2, 3, 4. All are correct, but it is not. Okay. Now see this question. Both transistors are perfectly matched. What do you mean by perfectly matched? They are having same mu and VT, same lambda. Okay. So what will be the value of current I? That would be 100 microampere. 100 microampere. No. Why? Because there is channel length modulation. If there is channel length modulation, what will be your current equation? Current equation could be mu n cox w by 2l VGS minus VT whole square into 1 plus lambda VDS. This would be your current equation, right? So lambda will come in action. So basically, let's just say in M1 I am telling ID1 current, in M2 I am telling ID2 current. Both will have same VGS. We can see here both are having same VT. Everything is same, but lambda is also same, but both will have different VDS, right? Both will have the different VDS value. So that is the main task here. So the current will be different here. ID1 we know, ID2 we need to find. VDS1 we know, VDS2 we need to find. Okay. So let's just say my ID2 is, intuitively how you will do it, that I will also tell. Okay. So I will tell intuitively only. Equation I will just write down. You can solve that particular equation. So let's see the intuition first. So let's first find the VDS value of this one. First find the VDS value of this one. Let's find the, if I know the gate potential here, then that would be same as VDS only, because this potential is G only. So first I will find the VDS value here. So 100 micro would be equals to 50 micro by 2 VGS minus VT whole square into 1 plus lambda VDS will also come, and VDS is equals to VGS, but that would be a very low value because lambda is already very low and VGS will also come very low. So for now we can ignore it. Generally when you find this value we can ignore it. This much approximation we can do. So we are ignoring this factor. Okay. So 4, 2, 3 we will get, right? 3 minus 1 is 2. 4. Yeah. So VGS equals to 3 we are getting. So VGS is equals to VDS1 we can say, that is equals to 3 volt. Now tell me one thing, I will give you the intuition now. If I say the current is completely copied here, if I say that 100 microampere current is copied here, then how much will be the voltage drop here? 10 to the power 5 into 10 to the power 5 into 10 to the power minus 4. ये तो कुछ ज़्यादा ही हो गया. 10 volt voltage drop we are having. 10 volt voltage drop we are having. Wait a second. So yeah, actually this is 10 kilo ohm, not 100 kilo ohm. Okay. So what will be the drop here? This would be 10 to the power 4. So basically the drop here is 1 volt because 100 microampere current is flowing. I am assuming that the current is mirrored. Now if current is mirrored, what is the VDS value you are getting? VDS of 2. That you are getting as 4 volt. And what is your VDS of 1? VDS of 1 is 3 volt. So if your VDS of 1 is 3 volt, at that time your VGS is same. Okay. Now I am drawing ID versus VDS curve. ID versus VDS curve. This is how the ID versus VDS curve will go for lambda not equals to 0. For lambda not equals to 0. Now this is for the same VGS because both are having the same VGS. This is for the same VGS. When you are at VDS equals to 3 volt, this is the current. Now you got to know that if you say that current is mirrored, if you say that 100 microampere current is flowing, if you say 100 microampere current is flowing, at that time your VDS is coming 4 volt. This was your VDS 3 volt, but actually your VDS is coming 4 volt. That means certainly your current will be greater than 100 microampere. Say yes or no. So which is the only option? That's it. Now if I change my circuit and put 25 kilo ohm here, if I put 25 kilo ohm here, then what will be my, and assume I am assuming that my current is being mirrored. If my current is mirrored, then what will be my voltage drop here? 2.5 volt, and this VDS will go down to 2.5 volt. So now you are here. Now you are in this region. Now you are in this region. This is your 2.5. So your current would be lesser than 100 microampere. So in that case, your answer would be lesser than 100 microampere. And if your if your RD is 20 kilo ohm, and assuming that the current is perfectly mirrored, RD is 20 kilo ohm, and you are assuming that current is perfectly mirrored, then what will be the voltage drop here? 2 volt, and then what will be the voltage here? 3 volt. So at this time you are actually here only. So your assumption that your current is perfectly mirrored, that is correct. If RD is 20 kilo ohm, if RD is 25 kilo ohm, that means VDS is lesser. That means the current will be lesser than 100 microampere. And if your RD is 10 kilo ohm, that means your VDS is greater than 3 volt. That means the current will be more. The current will be more. The current will be somewhat here. So here your VDS is more. So current would be more than that. Or you can solve by equation as well. So this was the intuition. First we will find the VGS value. Then we will assume the current is mirrored. So here VDS is 3 volt. Here VDS is something different. So our assumption that the current is mirrored, that is wrong. But VDS value we are getting larger. That means if we are getting larger VDS, that means more current would be there. Okay. So that's the scene. So let's remove it off. Let's remove everything. So this was the intuition. I hope you must have understood. If we assume the current mirror, okay. So this is the VDS we are getting. VDS of 2 is not actually 4 volt. Okay. If we mirror it, then we get 4 volt. And from there we go to know that certainly the current will be more than 100 microampere. Now what will be the VDS that we don't know? From here we can find. So what will be the VDS? If I am assuming I to be in milliampere, so what I can write? My ID1 is 100 micro. Divided by ID2 I need to find, that I am assuming as I. 1 plus lambda VDS1, that is 3. Lambda value also I know, that is 0.01 into 3. Divided by 1 plus lambda, what will be my VDS2? That would be 5 minus 10k into I. And lambda value also we know, that is 0.01. So only unknown here is I. So you need to find the value of I from here. So get I from here. Okay. So you need to get I from here. So you can solve this equation, you will get I, considering I to be in milliampere. This we have assumed here. I in milliampere. So from here you will get 0.10096. So this you will be getting here. Okay. So better, but this, the intention of this question was to give you the intuition. What is the intuition? the current is not perfectly mirrored here. Okay, because VDS is different, and if VDS is different, then either you can solve by this equation, or you can have the intuition that the VDS will be, if VDS is larger, that means current will be larger, and if VDS was lower, then current would have been lower only. Okay then. So let's see the solution of this problem. In this problem, what they are asking, they are saying there are two problems. So for in first one, they are saying the switch is closed, then the value of transconductance is GM1, and when the switch is open, the value of transconductance is GM2. Now tell me one thing: how do you determine GM1 or GM2? By doing the DC analysis. We will do the DC analysis. We will find the value of ID, right? And then we will find the GM. GM will be root 2 mu n Cux W by L into ID, right? Now, for both of the cases, mu n Cux W by L will be same. And if ID is same, then certainly for both of the cases, GM will also be same. Say yes or no. When switch is open and switch is closed. Now tell me one thing, whether switch is open or closed, in DC analysis, capacitor is going to be open circuited only, right? In DC analysis, capacitor will be open circuited. In DC analysis, in DC analysis, cap will be open circuited. And if capacitor is open circuited, what does that mean? That ID will be same only, right? ID will be same. ID1 will be equal to ID2, because circuit will be same, right? The circuit will be same, then ID will be same. That means GM1 would be equal to GM2. So this is the first thing we got to know, that in both of the cases GM will be same. So we can cut at least these two options. Now we have to differentiate between, now this answer is wrong actually. This I have already modified. This is wrong. This I have modified now. So yeah. So now we need to differentiate between these two options. So for that you have to do the calculation. And the calculation is a bit complex. I know that. The calculation is complex. But in the examination, these kind of questions may come up where you have to do the calculation. So either you can skip it, or you can simply go with the guess. And if not both of them, then you have to solve the problem. So we can solve the problem. Simply we need to apply the equations. So I already have the data. R1, R2 value is, these values are given, and VDD is 5 volt, right? So how much voltage will come here? You can simply do potential divider. It would be 1.67 volt. Okay. Then I can write down the equation. What equation I will get? Current I would be equals to mu n Cx W by 12, 4.7. I am considering current I to be in milliampere. Okay. VGS. VG is 1.67. What would be my source potential? Source potential will be 22.7 I minus VT is 0.5. VT is 0.5 whole square. So this equation you will solve and get the value of I. By solving this equation, I have already solved this equation. I get the value of I as 46.82 microampere. This is the value of I will get. Here you have to take care of milliampere, microampere, all these kind of things, because that is very important. Otherwise, because you are going to take the root here. So if you take the root of 10 square, if you take the root of 10, both will make a huge difference, right? So whenever there is the problem involves under root, there you need to take care of the power as well. Okay, so 10 to the power 6 is there. 10 to the power minus 6 is there. Okay, so this you need to take care. This is very important. 46.82 microampere we are getting. Okay, and then we just need to calculate the GM value. So GM value would be what? 2 into mu n Cx W by L into 2 into 4.7 milli, this is milli, into 46.82 micro, this is micro. So basically whatever the value you get, but inside what is happening, 10 to the power minus 9 is there. Inside 10 to the power minus 9 is there. So what I can do, I'm just telling the calculation here, because a lot of guys mess up here, that I know. Here 10 to the power minus 9 will be there, right? So what I can do, I will make it 10 to the power minus 8. If I am making it 10 to the power minus 8, that means I have to divide by 10. So this I will make 4.682. Now that would be the correct one. Okay. So a lot of guys do the calculation mistake. Now we will just calculate the value. And as far as I remember, we get 0.494 millisiemens. Or millimahu also you can say. So this is the value of GM, which is equals to GM1, and both are equal only. Why both are equal? Because the current is same for both of them. Okay. Now let's see the next one. In this question, what is the scene? Here you don't need to do the calculation. Why you don't need to do the calculation? When the switch is closed, what will be the gain? When switch is closed, what will be the gain? The gain would be GMRD, GM1RD, or GMRD, because in both of the case GM is same. That would be GMRD. This would be AV1. And when switch is open, that means it is degenerated. When switch is closed, it is not degenerated. RS will be gone. When switch is open, RS will be there. So for that, the gain would be negative actually. Minus GMRD upon 1 plus GMRS. If you find the ratio, AV1 by AV2, that would be 1 plus GMRS. And certainly it would be greater than 1. Right? It would be greater than 1. So only one option is there where it is greater than 1, that is 22.3. That's it. So you don't need to solve it. Okay. Otherwise, if you want to solve it, it is again very easy, because you already have the value of GM into RS. RS value we also know, that is 22.7. RS value is 22.7. So with the calculator, 22.7 into 0.94, 0.7 into 0.94 plus 1, so 22.33. I will tell you one interesting thing. What you could have done here is that you could know that this would be the answer. You wouldn't solve this problem. Okay. First you know that this is the answer. From here you could find the value of GM, because you know 1 plus GMRS would be equal to 22.3. From here you could have find the value of GM and take this option. This is what you would have done, right? So this is what these kind of things I used to do in JE. I used to solve one particular problem, and based on the answer of that particular problem, I used to find the other answer. So this you could have done smartly, but in the examination, if they are asking the same questions, then you can do this thing. Okay, just for effect I am telling. Okay, so yeah, I hope you must have understood. Okay, then let's see the solution of this one. You need to find small signal voltage gain, but here GMB is also given. I hope you know what is GMB. If I say here GMVGS is the current, if there is body effect present, then GMVGS will not be the only current. The current would be GMB, just G will be replaced with B. This is your body bias. Okay, and if nothing is given, body will be taken as ground. Here also body will be taken as small signal ground. Okay, body will always be taken as small signal ground if no small signal is applied there. Okay, so for that you can check out a video that I have made, MOS amplifier with body effect by Himanshu Agarwal. MOS amplifier with body effect by Himanshu Agarwal, PrepFusion. This you can type. Okay, in the analog electronics playlist also you can get this would be the last video of MOSFET amplifier. So there also you can check the complete concept I have given. What do you mean by body effect? Why in like body is connected to which potential? Why it is small signal ground? Everything is there. Okay, so this will also be this is V bias, DC voltage. This will also be small signal ground. So VGS is 0, VBS is 0. So no current component is 0. No core current component is there. Basically VGS is equals to 0 and VBS is also 0. So current component is 0 here. Only R0 is connected. What is that? RDS2. That is 23.89 kilo ohm. And what is the value of R? 4.6 kilo ohm. Okay. Now let's make the circuit again. And from V0 to ground, you will see this RDS2 as well. Sorry, RDS1 as well. From V0 to ground, because VDD will also be grounded. This will also be grounded. From V0 to ground, you will see RDS1 as well, right? So that also we have to make. So this is your V in, this is your body bias which is shorted, small signal ground it is, and now 4.6 plus 23.89, 4.6 plus 23.89, that would be 28.49 kilo ohm parallel to RDS1 which is 20.63. Okay, plus 20.63 reciprocal into 28.49 into 20.63. So we are getting roughly around 11.96 kilo ohm. 11.96 kilo ohm. And this is your V naught. So tell me how much current is coming from upper side. One current is coming, that is GM V in minus V naught. And another current is coming, that is G plus GMB. GM1 it is. This will be GMB V1. 0 minus V naught. That means minus V naught. 0 minus V naught would be VBS. Body is grounded. Source is at minus V naught. So this much current is coming. Okay. So what you can write? GM1 V in minus GM1 V naught minus GMB1 V naught into this resistance R, 11.96 kilo ohm, would be equals to V naught. So GM1 value, what is the value of GM1? 1.6 milli. 1.6 milli into 11.96. 1.6 into 11.96. 19.14. V in. And then minus GM1 plus GMB1. GM1 plus GMB1. GM1 plus GMB1. I am just doing the calculation, nothing else. So 1.6 milli plus 0.32 milli. 1.92 into 11.96. That would be 22.96 minus 22.96 plus 1. 23.96 is equals to 23.96 V naught. What would be your V naught by V in? Reciprocal into 19.14. 0.8 you are getting. Okay. So by solving it, we get 0.8. 0.79 something you are getting. So answer is 0.8. This is very simple problem. Just I wanted to introduce this GMB term, so that it may be introduced anywhere in the interview or in the gate examination. Anywhere it can be introduced someday. Till now it hasn't been introduced, but practically when you analyze a MOSFET amplifier, certainly there will be a body bias, certainly there will be a body effect, and this term also come practically this term also comes, so it can be asked in your examination. Okay, so that's why I wanted to introduce it. It was very simple, just the basic concept you need to know. Let's see the solution of this one. So in the first question, the switch is connected at 1. Okay, so switch is connected at 1. Gate and drain are shorted. That means it is working in saturation region. That's for sure. What you need to find, there is something that is defined as R naught, which they are saying as VDS by ID. So your target is to find VDS by ID. So for the question 1, I know VDS is 3 volt. What is my ID? That I will find. That's it. That would be my final answer. And this is certainly working in saturation region because gate and drain are shorted. So ID would be equals to what? ID would be equals to Kn mu n CX W by L, VGS 3 minus VT, VGS minus VT whole square. So 2.8 whole square. 2.8 whole square. into 0.445. So 3.488 milliampere. Okay. And so what will be your R naught? R naught will be 3 divided by 3.488 milli. So reciprocal into 3. 860. So yeah, here answer would be 860 only. I just checked it. So there is some error here. I will improve it. Answer would be 860. Okay, and what is the next question? The switch is at the switch is at position B, position 2. The switch is here. If the switch is at position 2, then VGS will be 0, right? For the second question, if the switch is here, then VGS will be 0. And if VGS is 0, that means current ID is 0. And if current ID is 0, that means R naught, that would be VDS by ID, which is 0. So that would be infinity. So option is 1, infinite. Okay. So this I need to improve. What kind of sampling, what kind of feedback topology is there? So this is your V naught, this is your V naught. So this current would be GM V naught. So your voltage is being sampled. There is no use of I naught current, right? Your voltage is being sampled and current is being mixed. So voltage sampling and current mixing. Sampling is written first. So that's it. And what could be the other name? So current is being mixed. Current is mixed in shunt. And voltage is being sampled. Voltage is sampled in shunt. Shunt. 1 and 3 is the correct option. Okay. So if you just know the feedback topology, then you will be able to solve it very easily. Okay, then thank you. So for the solution of this one, this is a standard circuit only, right? Standard circuit. What is the resistance? So looking from source, the resistance we get RDS plus R upon 1 plus GM RDS. You can derive it as well, but generally we remember this formula. How you will derive it? You will put RDS here. You need to find resistance from here, so you will apply Vx from here and get Ix current out of it. Now Ix will be divided between these two, and here also Ix current will flow. What will be this node? This node will be minus Ix into R. Sorry, plus Ix into R. This node will be plus Ix into R. Ix into R, because this current is flowing and this will be AC ground, right? So then you can simply apply the nodal. Although derivation we should remember, or what would be the current in the upward direction in MOS? That would be GMVx. So simply in one equation only you will be able to get the answer. What that would be? Vx minus Ix into R divided by RDS plus GMVx is equals to Ix. So Vx would be here 1 by RDS, so 1 plus GM RDS divided by RDS is equals to Ix into RDS plus R divided by RDS. So Vx by Ix would be, that would be RDS plus R upon 1 plus GM RDS. So very simple derivation, but you need to remember it. Okay, you should remember it. So let's see the solution of this one. You need to find ID and GM. So from the diagram you can see at point A you need to find the value of ID. So from the diagram you see it is near to 4. So which option is matching? These two. So ID I can see here, that is 3.488 milliampere. And what about GM? What is the formula of GM? That is root 2 mu n Cux W by L into ID. So that is root 2 mu n Cux W by L, that is 2 into 0.445 milli into ID is 3.488 milli. So basically you need to take the under root later on. 0.455, 0.445 into 3.488 into 4 under root. So 2.5 millisiemens you are getting. So this is the answer. Okay. What about this question? You need to find the small signal transconductance. This is actually 5 volt, not ampere. I hope you must have understood. In the node, if I am saying minus 5A, that means it should be voltage. So that much error by typewriter you can take, right? So this is minus 5 volt. And what you need to find, small signal transconductance. You need to find the GM value. So for GM value, you are already having mu n CX W by L value. So 2 into mu n CX W by L. Now you need ID value. Tell me what will be the ID? What will be the current in the MOS? 1 milliampere only, no? Right? Because this 1 milliampere will be flowing from here as well. This 1 milliampere will be flowing from here as well. This cap will be open circuited. This cap will be open circuited. So 1 milliampere will be flowing from here as well. So this is the current. That's it. Right? So GM would be equals to into ID. So GM would be equals to root 2 into 2 into 1 milli into 1 milli. So basically 2 milli is the answer. Okay, 2 milliampere per volt. So this is the correct answer. Very easy. This is a very standard circuit, CMOS inverter. You need to do the small signal analysis. So what you can do? Better you should find it with GMR out method. So I hope you remember the GMR out method. What will be the gain? Capital GM into R out. How do you find the capital GM? You short circuit the output. You find the current here. What that current would be? This will also be shorted. This is V in. So current in the upward direction would be GM2 V in. Current in the downward direction would be GM1 V in. So this is our ISC current. So ISC current is minus GM1 plus GM2 into V in. And how our capital GM is defined? Capital GM is defined as ISC divided by V in. So that would be minus GM1 plus GM2. And what you need to find now? R out. So for R out, what will happen? Input will be shorted. If input is gone, so only RDS1 will be here and RDS2 will be here. Because VGS is gone, here also VGS is gone. So RDS1 parallel with RDS2. RDS1 parallel with RDS2. So what will be the gain? The gain will be minus GM1 plus GM2 into RDS1 parallel with RDS2. Very standard circuit. Generally people remember the gain as well. Okay, but I am not asking you to remember. You can derive it very quickly without even writing much equations. Okay then. Here mu n CX value are given, mu p CX value is given, Vt value is given, W by L value is given. You need to find the value of V. So both of the transistors will drive the same current and both are working in saturation region. Say yes or no. Why both are working in saturation region? Because drain and gate are shorted. Drain and gate are shorted. So both are working in saturation region. So what I can write? Mu n CX W by L, right? Mu n CX W by L into VGS. VGS of this is V minus Vt whole square would be equals to mu p COX. W by L is the same for both of them. VGS, what is VGS? 3 minus V. VSG, sorry, VSG. VSG is 3 minus V minus Vt is 1. Right? Now I can replace mu n COX equals to 2.5 mu p COX. Mu n COX can be replaced with 2.5 mu p COX. So this is 2.5 only. Right? 2.5 V minus 1 whole square is equals to 2 minus V whole square. Tell me one thing, V value will be positive or negative? It will be positive. So I can take under root. Right? I can take root. So 2.5 under root. So 1.58. So 1.58 V minus 1.58 is equals to 2 minus V. Right? So 3.58 V. I am taking under root without the negative sign because V value will be positive. Okay? So I took the under root here. So V would come here. So 2.58 V is equals to 3.58. So V value I can get from here 3.58 plus 1 reciprocal into 3.58. 1.38. 1.386. Basically 1.386 I am getting volt, which can be taken as 1.39 volt. So that's it. That is the answer. Okay. So in calculation, people would have tried quadratic equation there and then it would be complex. But better than that, take under root. And here I will take under root with the positive sign because I know V would be positive. Okay then? Yeah. So in this question, you need to find the value of Vp. Okay. Actually, the typewriter forgot to show the slope here. But even if he has forgot, still you can tell the value of Vp. How you can tell the value of Vp? Because both elements are same here. Both elements are same here. Then that means both resistance, both of them will provide the same resistance, right? Both elements are same. Both of them will provide the same small signal resistance. or even the large signal resistance, both will provide the same thing. No, if element is same, that means both will provide the same amount of impedance, right? You don't know the value of impedance, you don't know the operating point, you know nothing, but you know one thing, that both will provide the same impedance. If both are providing the same impedance, that means what will be your V naught? V naught will simply be equals to V in by 2. Better I should write capital V naught should be equals to V in by 2, because DC AC both will be there. So simply your V naught will be equals to 3 volt plus 1.5 millivolt sine omega t. So what is the value of Vp? 1.5 millivolt. So this is the answer. Very easy problem. It could have been a better problem if the waveform was given here, but he forgot it, so we cannot do anything. So this is the correct answer now. Okay. Basically the DC part is there and the AC part is there, but both elements are same, both will provide the same impedance. If both are providing the same impedance, then simply V naught will be equals to V in by 2, no matter whether it is AC or it is DC. So 3 volt plus 1.5 millivolt sin omega t. So answer is Vp value is 1.5 millivolt. Okay, very easy. So in this question you need to find the GM and R naught value. Okay, so lambda value is 0. If lambda is equals to 0, then certainly your R naught is infinity only. So there is no doubt about R naught. Now the question is, how do you find GM? So for GM, what you need? You need the value of ID. So for that, let's see this circuit. So this capacitor will be open circuited. This capacitor will also be open circuited. Both capacitors will be open circuited. So how will the circuit look like? This is the 5 volt. Then there is 1.2 kilo ohm, right? Then there is this MOS. Gate is grounded. Then across the source there is this 1.2 kilo ohm, and then there is minus 5 volt. Although this was not necessary, drawing this was not necessary, but just to explain I have drawn it so that you might see it better. So this is the current I, right? This current would be your I. So what I can say, I is equals to mu n I is equals to mu n CX W by L, that is W by 12, that is 1 1 milli. What would be VSG? VSG would be 5 minus 1.2 I minus what is VT? VT is minus 1.5 whole square. So this is the equation we are getting, considering I to be in milliampere. Considering I to be in milliampere, and if I am considering I to be in milliampere, I can remove this milli part from here. Okay. So this equation we will get from here. You can find the value of I. You can solve this equation and find the value of I. I have already calculated a kind of a bit of complex calculation it will be, but you should be able to solve it because we have already solved a lot of problems like that. So this is the value of I we are getting. So how we will get the GM value? GM value we will get as root 2 mu n CX W by L. So again 2 milli, because twice Kn is 1 milli, so mu n CX W by L would be 2 milli into 1.79 milli. Okay. So after solving this, we will get 2.68 milliampere per volt. Okay, so this is the answer. So just a bit of a complex calculation is there, but the question was easy. Okay. Now in this one, what they are asking, 3 dB frequency due to CC1. So across CC1, what is the impedance you see? 0. Across CC1. You see from here 1 by GM parallel with 1.2 kilo ohm, 1 by GM. So GM value we have got 2.68. So what is the value of 1 by GM? So that I have to calculate. 2.68 we have got, 2.68 reciprocal. So 0.1 by GM is equals to 0.373 kilo ohm. Okay. And what is the equivalent resistance? 0.2 kilo plus 1.2 kilo parallel with 0.373 kilo. This is the equivalent resistance. Okay, across CC1. And you in hertz you need to find. So this is 0.2 kilo ohm. What will be the parallel combination of this one? Into 1.2 divided by 1.573. 0.284 kilo ohm. Okay, plus 0.2, 0.484 kilo ohm. and capacitance is, total capacitance is 4.7 microfarad, right? So, so what will be our 3 dB frequency they are asking, omega 3 dB they are asking, so that would be not omega 3 dB, frequency they are asking, frequency 3 dB they are asking. So 1 by 2 into pi into 4.7 micro into 0.484 kilo, right? So 10 to the power minus 3 already you are getting, so upper side it would be 10 to the power 3. So let's calculate, into 4.7 into 2 into pi and then reciprocal into 1000. So almost around 69.86 we are getting, 69.86 hertz, which is nearly around 70 hertz. So answer is option A. So this is how we calculate the 3 dB frequency due to one of the cap. We just find the equivalent resistance across the cap. So what will be the equivalent resistance? This resistance parallel to this resistance and in series with this resistance. Okay. And in this question you need to find because of CC2. So because of CC2, then CC1 will be shorted. So all this resistance will be gone. This node will also be gone. So there will be no current from here. So only across CC2 you would see 1.2K and 50K. These kind of examples we have seen in the class notes only. So across CC2 you would see 1.2K and 50K, right? And both will be in series. So what is the equivalent resistance? That is 51.2 kilo ohm. And the capacitance CC2 is given as 1 microfarad. So what will be the frequency? That would be 1000, because these two will be multiplied, 10 to the power minus 3 will be there, which will come upward, into 2 into pi into 51.2 into 1, right? So 2 into pi into 51.2 and then reciprocal of that into 1000, 3.1. So we are getting 3.1 hertz. So that is the answer. Very easy question, very straightforward, right? So this question generally we study in digital electronics. Okay, generally we study about the power dissipation in digital electronics. So what is the dynamic power dissipation in CMOS? That is equals to C VDD square by T, or you can say F. Okay, there are some leakage as well, those term also comes. So basically dynamic power dissipation is proportional to the frequency, right? So it is proportional to the frequency. This we will study in digital electronics. Okay, power dissipation. Now what they are saying, input resistance is equals to 200 kilo ohm. So what is the input resistance? That is R1 parallel R2. So R1 parallel R2 is equals to 200 kilo ohm, right? Now you would think that, sir, we will calculate R1 parallel R2, which one is 200 kilo ohm, then we will write down our answer. So if you solve all four problems, I guess in all 4 conditions you will get R1 parallel R2 equals to 200 kilo ohm in all 4 conditions. So this is what you cannot do. You have to find one of R1 and R2. So let's try finding one of R1 and R2. So what we can do here? We know the current, right? And we know this drop as well. This drop is 0.25. We know this drop as well. DC analysis if we are doing, that is 9 R2 upon R1 plus R2. So I will try to find VGS. First I will try to find VGS, and then I can relate with 9 R2 upon R1 plus R2. So my target is to find VGS now. Okay, then let's start. And this value is R1 R2 upon R1 plus R2. R1 R2 upon R1 plus R2 is equals to 200 kilo ohm. Okay. Now my target is to find VGS. So 0.5 milli is equals to mu n CoX W by 2L VGS minus VT whole square. So 2.5 under root plus 1.5. 2.5 under root plus 1.5. Under root plus 1.5. So that would be 3.08. VGS is 3.08, and that is equals to 12 sorry 9 into R2 upon R1 plus R2 is equals to 3.08. So R2 upon R1 plus R2, 3.08 divided by 9. So that is equals to 0.342. So from here I can get the value of R1, right? Because I know this value, I will put this value here. reciprocal of that into 200. So I am getting 584. R1 value I am getting 584 किलो ओम. 584 तो कहीं ऑप्शन में नहीं है यार. लेट्स चेक बैक अगेन. 0.5 milli is equals to 0.2 milli VGS minus VT whole square. Okay, then 5 by 2 would be 2.5, and R1 parallel R2 is input resistance is given, that is 2 kilo ohm only. R1 R2 upon R1 plus R2. Okay, then 5 by 2 is 2.5, and take 2.5 under root, that is 1.58. I cannot take minus sign because VGS value I need. Okay, this is not VGS value, sorry. This is VGS value. This value is VGS. So here we did it wrong. This went wrong. So this value is VGS, but VGS is 9R2 and then 0.25 is equals to 3.08, right? So this is the mistake we did here. 9R2 upon R1 plus R2 is equals to 3.08 plus 0.25 divided by 9 is equals to 0.37. So this value is 0.37, which I can put here, reciprocal into 200. So 541 I am getting. So from here value of R1 I am getting is 541 kilo ohm. Okay, so only one option is there, and then you can get the value of R2 as well. So this is the way. Okay, first R1 R2 upon R1 plus R2, then from there I got the value of R1 and then R2. So VGS value I determined from there. Okay, then now this question is based on past transistor logic. 3 circuits are there. First one is threshold voltage for all the transistors is 1 volt, and tell the steady state value of VO1. So this has the ability to charge till 5 volt, and VT is greater than, VT is 1 volt, that means VGS should be greater than 1 volt as well. So this would be 5 volt only. So answer is 5 volt. I hope you know the concept of past transistor logic. Otherwise you can go and type on YouTube past transistor logic by Himanshu Agrawal. You will find the video. So here we need to make sure two things, that VGS should be greater than VT at steady state. At steady state actually VGS should be equals to VT, and VDS should be greater than 0 or equals to 0. These two conditions we need to make sure. That's it. Okay, so from there we are getting 5 volt. Let's see the next one. These two are the good question, but straight from our class notes only. Here what they are saying, Vx2 is 3 volt. Vx2 is 3 volt. So capacitor is charged to 3 volt initially, and Vx1 is 0.5 volt. This is 0.5 volt. So this capacitor is charged to 0.5 volt. Now tell me one thing. Now you should have a good idea of switch capacitor, then only you will be able to solve it. Okay. So tell me one thing. In the whole circuit, same current will flow, right? Same current will flow. I is same. If I is same, then what is I? I is dq by dt. Then change in charge will be same. Change in charge will be same. For the capacitor, what is I? That is C dVc by dt, right? So this C into dVc, that would be same, right? C into dVc would be same. Let me make the circuit now. This is the second circuit. This is the circuit. This node is at 2 volt. This is grounded. This is charged to 0.5 volt. This is capacitor 2C, and this is capacitor C. Okay. Current will be flowing in this direction. This is 3 volt. First tell me one thing. Will the current will flow in this direction? No. Source is having 3 volt and drain is having 0.5 volt. So which one will be drain? Which one will be source? This one will be drain, right? This will act as drain because the one having more potential. What is this? This is NMOS, and in case of NMOS, the one having more potential acts as drain, and this will act as source. So the current will flow from here to here. Now tell me one thing. If the current will flow upward side, that means this will lose some charge. Let's just say if this lose delta V voltage, then how much voltage this will gain? Can you tell me? It will be delta V by 2. Why is that so? Because if C is losing delta V voltage, so this much charge it is losing, then how much charge C by 2C will get? How much charge 2C will get? So 2C will get delta V by 2. Say yes or no. If this is losing delta V, then it will get delta V by 2. Because C into delta V has to be constant. This has to be constant. Right? So this is having 0.5 plus delta V by 2 and this is having 3 minus delta V. Now at steady state what will happen? VGS will be equals to VT. First condition is at steady state VGS equals to VT, and the other condition is also there, that VDS equals to 0. If one of them reaches first, at that time we will have the steady state. One of them should reach first. Which one will reach first? Let's check that out. So VGS is equals to VT. This is your source, this is your drain, this is your source. So VGS, so 2 minus 0.5 minus delta V by 2 is equals to 1 volt. So from here delta V what we get? 1.5 minus 1, 0.5 into 2, 0.5 into 2, that means delta V you are getting 1 volt. What does that mean? That this will charge to, if delta V you are getting 1 volt, that means this will charge to 1 volt, because 1 by 2 is 0.5, 0.5 plus 0.5 is 1, and this will be at 2 volt. So this will charge to 1 volt and this will be at 2 volt. This is the steady state, right? Because here VDS is 1 volt. In this condition, now in this condition VDS is 1 volt, and that is acceptable, right? If VDS is 1 volt and VGS is equals to VT, that is the steady state, because this capacitor 2C cannot charge further. But if we calculate this value and we get to know that my VDS is negative, that means something is wrong, because VDS cannot be negative. VDS can have can go down till 0 only, but here VDS is 1, that is acceptable, and delta V is 1 volt. So this capacitor will charge to 1 volt and this will be at 2 volt. So basically our Vx2 will be 2 volt, Vx2 will be 2 volt and Vx1 will be 1 volt. So that is our steady state. Let's check out the next question. In next question the condition will change. Let's throw this one. So here this is at 8 volt. Initially this capacitor Vx4 is having 1 volt. This is having 1 volt. This is capacitor 2C, and Vx3 is 2 volt. So basically this is having 2 volt. Now this is 2 volt, this is at 1 volt. So this will act as drain only and this will act as source, right? So current will flow in this direction, and this is C, this is 2C. Now tell me one thing, if this loses delta V, because current will flow out of this, then how much this will gain? Delta V by 2, right? Are you getting this point? If that one loses delta V, this will gain delta V by 2. Now two conditions are there. VGS is equals to VT at steady state. If I say VGS, what will be my VGS? 8 minus 1 minus delta V by 2 is equals to VT, that is 1. So 7 minus 1, 6, delta V is equals to 12. So delta V we are getting 12. Delta V we are getting 12. So what will happen? 1 plus 12 by 2, 6. So that will be at 7 volt. And what about this? This will be at minus 10 volt. Is that possible? This will be at minus 10 volt. Is that possible? Your VDS here, VDS is minus 10 minus 7, minus 17 volt, which is not possible. So what was happening here? The charge was flowing from upward side, the charge was coming, but it cannot go up to 7 volt, because this 2 volt doesn't have that much of potential to deliver that much of charge. Are you getting this point? So this is wrong. Why this is wrong? Because the 2 volt doesn't have that capability. So how much charge 2 volt can deliver? At that time VDS has to be 0. So 2 minus delta V is equals to the source potential, that is 1 plus delta V by 2. 2 minus delta V, 1 plus delta V by 2. So 1 is equals to 3 delta V by 2. So delta V is equals to 2 by 3. So from here what we are getting? Delta V is equals to 2 by 3. So what will be your Vx3? So your Vx3 will be 2 minus 2 by 3. 2 minus 2 by 3. 2 by 3 is 0.67. So that would be 1.33. And what will be your Vx4? That would be 1 plus 1 by 3. That would also be 1.33. Obviously, drain and source has to be same only. So both will be 1.33 volt. Okay. So option is C. Did you understand this concept? And there is fusion special assignment is there on our channel, on PrepFusion channel only. There we have solved these kind of problems. So certainly these questions will come in your written test, in your gate examination, in your interview. So very good kind of problems these are. So there we have solved these kind of problems. A lot of problems are there. So you can go and check out that assignment. Fusion special in MOSFET amplifier part only you will get. Go to the analog electronics playlist. In MOSFET amplifier part you will get these kind of questions. Okay. So you can check that out. Basically you need to see how much charge can flow. So here it wanted to charge up to 7 volt, but it cannot charge because 2 volt will not be able to deliver that. In this question 3 volt was delivering voltage here. So it wanted to charge up to 1 volt only and it was able to deliver that. But here it was not able to deliver that. Okay. So your answer is this. Well and good. So what kind of amplifier is that? How we will check? By the sampling and mixing. So current mixing is there, certainly current mixing is there. If this is the current, then it can be divided into two parts. You will not say that sir input current is 0. It still has the two parts, it can be divided. So current mixing is there. And what about sampling? Voltage sampling is there because from the feedback direct V node is connected. From feedback direct V node is connected. So from here some part of V node can come. So voltage sampling and current mixing. So voltage by current, output by input, voltage by current is resistance. So trans resistance amplifier it is. Same as non-inverting amplifier using op-amp. Sorry, inverting amplifier using op-amp. Inverting amplifier using op-amp is also trans resistance amplifier because there also voltage sampling and current mixing. So that's why it is trans resistance amplifier. So let's see the solution of this one. You need to find the value of I. So how can you find the value of I? Basically, you have the Kn relation, you know the Kn values. And Kn is mu n CoX W by L, you know the Vt value. You can find out this potential. If you know this potential, this will also be X, then you can find out the current very easily. So I know Kn1, that is 400 micro. Better I should write here. Basically 400 micro mu n CoX W by 2L. Kn1 it is Vsg, that is 0 minus X minus Vt whole square should be equals to 200 micro Vsg, that is X plus 5 minus Vt whole square. Okay, from here you need to find the value of X. So that would be a bit complex calculation, but we have to do it no other way. So X square plus 1 plus 2X, and here X square, X plus 4 it would be, right? X square plus 16 plus 8X. So 2X square minus X square would be X square, plus 2 minus 16 would be minus 14, and better minus 14 we will write later on. 4X minus 8X, that would be minus 4X. 2 minus 16 minus 14 should be equals to 0. So X value minus B plus minus root B square minus 4AC upon 2A. But value should be negative, X value should be negative. Why it should be negative? Because if it is positive, then the transistor will not even turn on. This is 0. If this is positive, then VGS would be negative. Then transistor will not even turn on. So it has to be negative. So 56 plus 16. Then 56 plus 16. Then take under root minus 4 divided by 2. So minus 2.24. Minus 2.24. That would be the potential of this point. Okay, minus 2.24. Now what you need to find? You need to find the current. So if you solve these kind of problems with good amount of patience, then you will be able to solve it very quickly. So in this equation I can put 400 micro 2.24 minus 1 whole square, that's it. This is the answer. So minus 1 whole square into 4, so 6.18. So 6.1 and then 0.62 milliampere. After solving it, this is what you will get, 0.62 milliampere. Well and good. 0.62 milliampere. Let's see this one. This is also very straightforward. 200 microampere current is there and all the parameters are identical. So both of the MOSFETs are identical. So this is 200 microampere current. So this will drive 100 microampere current and this will also drive 100 microampere current. Both will drive 100, right? So it will drive 100 micro. This is also driving 100 micro. So what will be the drop here? This drop will be 4 volt. So what will be V1? V1 will be equals to 1 volt and V2 will also be equals to 1 volt, right? So two options are there. Now do I need to solve this one? No. Why so? Because I know the transistor will be on, and if transistor is on and gate is at 0 potential, that means source will be at negative potential, no? So V3 will be negative, that's it. Are you getting this point? In the examination, how would you solve it quickly? 1 volt, I know only two options are left. One is saying minus 1.32, one is saying plus 1.32. If it is plus 1.32, then certainly the transistor will not be on. Because if this potential is plus 1.32, then transistor will not be on. So it has to be on. So if it is on, that means source has to go to negative. So option is B. Or what you can do, you can simply assume a potential here. Basically, you can find the value. How will you find the value? How much current is flowing here? 100 micro. What region of operation you will assume? Assuming saturation. 100 micro current is flowing, that would be equals to mu n Cux, that is equals to 100 micro into W by L by 2 VGS minus VT whole square. So 0.1 under root is equals to VGS minus 1. So VGS is equals to 1.32 volt. Gate is at 0, so Vs is equals to minus 1.32 volt. Very straightforward, right? Okay then. Now let's see this question. For all the transistor lambda is 0. If lambda is 0, that means if this is your V naught, then how much current it will drive? In the upward direction, it will drive GM V naught current, right? VSG is 0. You know the method. How do we write down the current? So in the upward direction, it will drive GM V naught current. Small signal GM V naught current. So here there is GM V naught current. This is your GM V naught current. Now what this will be replaced with? The upper one, the lower one. This is your V in. This is your V in, and this will be simply replaced with 1 by GM, right? From here to here, from downward, what do you see? 1 by GM parallel R naught, but R naught is not there, so it will be replaced with 1 by GM. All transistors are identical only. For all transistor, no, sorry. This is GM2. This is actually GM2. This is actually GM2 V naught. These two transistors are identical. This is GM1 and this is M1. So tell me what will be this potential, and in the upward direction there is GM2 V naught current. What will be this potential? Can you tell me directly without applying any equations? It will be V in by 2. Why is that so? Why this potential will be V in by 2? Because from here to here, I told you one thing. These kind of circuits are there. This kind of circuit we have studied in common drain amplifier. So what did I tell you? From here to here, I always see 1 by GM. So RD upon RD plus 1 by GM. Potential divider I can apply directly. So this will be my V naught. V naught will be RD upon RD plus 1 by GM. And if this is your V. So GM RD upon 1 plus GM RD. So directly I see 1 by GM here. So 1 by GM and 1 by GM. So this will be V in by 2. Right? Are you getting this point? Here I see 1 by GM and another 1 by GM is there. So directly potential divide I can do. So what will be the current here? GM V in by 2. GM1 V in by 2. 1 by GM, 1 by GM. GM1 V in by 2. So the current downward is GM1 V in by 2. So basically what you got, only in one line only you will be able to answer it. GM1 V in by 2 would be equals to minus GM2 V naught, right? This upward current, if I interchange the direction, it would be minus GM2 V naught. So what will be your V naught by V in? V naught by V in, that would be minus GM1 divided by 2 GM2. That's it. So option 2 is correct. Okay, good question it was. Quickly you would have been able to solve if you have good idea of small signal analysis. Okay, so a good idea of small signal analysis is required. Certainly it is required. Let's see this question. This is also a good question. So all transistors are identical. GM R naught is equals to 1. The transistors are biased in saturation region, and this is a small signal model have been shown. You have to find small signal voltage gain. So what do you think what this will be replaced with? All transistors are identical. This will be replaced with 1 by Gm parallel with R0. From V0 to ground, what do you see? 1 by Gm parallel with R0, right? From V0 to ground. So I can say from V0 to ground, I see one resistance, that is 1 by Gm parallel with R0. So I am denoting it with R. I am denoting this resistance with R. From V0 to ground, that is 1 by Gm parallel with R0. And here we have applied V in. Then from this node to ground, what do you see? Tell me. From this particular node to ground, again 1 by Gm parallel with R0. Say yes or no? So again I am denoting it with R. What I am saying, from this particular node to ground, what do you see? From here to ground, 1 by Gm parallel with R0, right? And then this is the resistance R0. Are you able to understand this concept? Very easy. And where is our V0? This is our V0. Tell me one thing. If I current is flowing here, then this I current will be divided in this loop, and then again I current will come out. Do you agree to this point? I am calling this potential as V dash. So V0 is my IR. What will be my V0? V0 is my minus IR, right? V0 is my minus IR. What will be V dash? V dash will be IR. So V dash will be equals to minus V0. So this node is minus V0 only. Are you getting this point? This node is minus V0 only. Did you understand this point? Very easy. From upward I current is flowing, that will be divided in two parts. So and then I current only will flow. So this is V0, this will be minus V0. Right? So what will be the current in this MOS? That would be Gm V in plus V0. Right? Because Gm VGS will be currents. So Gm V in plus V0. दिख नहीं रहा यहाँ पे. This is R0 is there. So Gm V in plus V0. So basically now I can apply nodal on this V0 node. So V0 by R, that is outward current, plus Gm V in plus Gm V0 plus V0 minus V0, that means 2 V0 by R0 is equals to 0. Do you agree to this equation? V0 by R plus Gm V in plus Gm V0 plus 2 V0 by R0, right? I have to add a page. Just if you just keep on writing the things that you know, you will be able to get to the final solution. That's my short guarantee. Okay. So V0 by R plus V0 by 1 upon Gm plus V0 by R0 by 2. That would be equals to minus Gm V in. So V0 by V in would be equals to what? Minus Gm into R parallel with 1 by Gm parallel with R0 by 2. So minus Gm. What was your R? R was 1 by Gm parallel with R0, right? 1 by Gm parallel with R0, parallel with 1 by Gm parallel with R0 by 2. So 1 by Gm parallel with 1 by Gm, what it will give you? R parallel R. R parallel R will give you R by 2. And what is our R? 1 by Gm. So 1 by 2 Gm it will give you. Not 2 by Gm, okay? Don't do these kind of error. 1 by Gm parallel with 1 by Gm would be 1 by 2 Gm. And R0 parallel R0 parallel R0 by 2. What it will give me? Give me R0 square by 2 plus 3 R0 by 2. So basically R0 by 3. So this will give me R0 by 3. R0 by 3. Now what this parallel combination will give me? 1 by 2 Gm into R0 by 3 plus 1 by 2 Gm plus R0 by 3. So R0 upon 3 plus 2 Gm R0, right? So this will be minus Gm into R0 upon 3 plus 2 Gm R0. Well and good. No issue. Yeah, all correct. So what is Gm R0? Gm R0 is 1. So minus 1 by 5. That's it. This is your voltage gain. This is the voltage gain we are having. Okay then. So in this problem you have to find the small signal differential voltage gain you need to find. So how you can do it? Small signal differential voltage gain. So I can apply the concept of half circuit. So what this will be replaced with? Basically I will apply the concept of half circuit here. I will apply the concept of half circuit. So this will be RL by 2. Basically this resistance will be RD parallel RL by 2. Because RL by 2 will come. So RD parallel RL by 2. RL by 2 will be replaced here. RD parallel RL by 2. And this node will be grounded. Right? And even this node will also be grounded. That's why they are coming in parallel. I hope you know the concept of half circuit. Even if you don't know, no need to worry. In the interview, it is very rare. If you are someone from M.tech, then you should be good enough with the differential amplifiers. But in B.tech or if you are preparing for internship, there is very rare chance that they will go into differential amplifiers. Okay, very rare chance. Even if you don't know, you can skip it. Because I do not recommend you studying the complete differential amplifier now. Because that will take a lot of time. So you can skip it as of now. Okay, but those who know the concept of half circuit, simply it will be replaced with ground. This will also be replaced with ground. So RD parallel to RL by 2 and this is RS. So what will be the differential gain? Only one stage gain I can write. That would be what this is coming. This is becoming common source amplifier with degeneration. So what is that gain? GM RD parallel RL by 2. These are very standard circuits. So and we solve it again and again. So we kind of remember the result upon 1 plus GM RS. What is my RS? RS is RS only. So is that the answer? No, negative sign will come because here you have applied positive potential and at this node only you are calculating. So if this node goes up, this node will actually go down and this here you are having the positive sign. So this negative will come. So answer 3 is correct, not this one. Okay. So negative sign would be coming because if this node is going up, this node is going down and here you are calculating. If this sign was like this, then your answer would be this one. But not, this is not correct because our sign is positive to negative. So negative sign will come. So option C is correct. Okay. Easy.